Hello and good morning, everybody, and thank you for joining us in our Ansys Virtual Academy, doing some simulations in the new Discovery Live. And in the title, you can see that it says instantaneous mechanical simulations or responses, and that's because Discovery is a different type of product than your typical simulation programs. Discovery uses the power of your graphics card to instantaneously solve your problems as you make the changes. And normally I'm joined by my colleague Snigdha Sakar. She is the applications engineer that specializes in CFD in our team. She's on vacation this week for Thanksgiving. And I'm your applications engineer on the structural side. Now, for today's agenda, we're just going to jump straight to a demonstration. I'm going to go over the new graphics user interface for Discovery. And we're going to start with the Explore solver. And that is where we have the tools similar to Discovery Live, where you're making changes and you're seeing instantaneous results. And then we're going to take that a little further and look at the new analysis solver in Discovery, where you can leverage the Ansys APDL solver to do a higher fidelity simulation, as well as getting access to different type of tools to do your simulation. And I'll explain those in the demonstration. So let's get started. I'm gonna minimize this. And when you first open Ansys Discovery, you're gonna be welcomed with this screen here. And if you jump through these tabs, it's gonna give you short videos and descriptions on Discovery GUI itself and how to get started. And I believe that if you ran through these short videos, you'd already be pretty proficient in using the Ansys Discovery tool. That's if you already had experience. And I'm going to close this down because I'm going to go over the GUI myself. Oh, and one more thing. It's the home page for Ansys Discovery. You could click on samples and do some sample simulations that have already been run. So you can see how those were done, and then you could replicate and copy that and see how proficient you are at the Discovery product. Now, you might have heard of Ansys Discovery Live. That's the old product. It has a different graphics user interface. And this is the new Discovery. So it's not called Discovery Live anymore. It's called Discovery. And what Discovery does is they upgraded the user interface and they made it more easy on your eyes. You can already see that it has a lot more grays and darks. And you can see a new tab over here called Simulation. And we're going to cover that a little later on why there's a Simulation tab. But first, let's go over the top portion of Discovery, where you have your ribbons. If you work from left to right, you have different to do what you want simulation-wise or even modeling. So if you're familiar with Ansys Space Claim, Discovery has Space Claim built into it, where I can start drawing things and I could pull those features, or I could do pretty much a lot of different type of tools that you find in your CAD systems. I can do that here too. So it has Space Claim built into it. That is a 3D manipulating modeler. It's not like your traditional CAD. So as I do these features here, there is no history. There's no history of everything I've done, the sketch that I've made, or any constraints that I've made. It's just a solid geometry. And that actually works to my benefit because I can quickly make changes to these and there won't be any consequences. And what I mean by that is, say if I pull this feature and make a radius, I can hit this radius and hit the delete key. And there's no parent-child relationships like a traditional CAD has, where you could change, you might get an error, and you might have ruined the child-parent relationships. So that's to my advantage in this program. Okay. This all junk. So up on the top left here, you could see a tree. As I continue to add bodies, you're going to see it's going to add more solid objects here. So that represents these different bodies I'm making. So now I have 4 different solid body objects here. I could easily click them all and delete them. And then you're going to see a physics tab over here as well below. You're going to see a physics tab over here. And that's where my simulation my simulation boundary conditions and loads will appear. So let's actually do a simulation right now. So I'm going to click open. We're going to save this. And you can see that Discovery, just like Discovery Live, is CAD agnostic. You have a full list of different type of CAD files that it supports. From SolidWorks, CATIA, Inventor, all the popular ones are here. Now I'm going to open up a space clean file. And we're going to do a simulation today on the suspension of a rare truck. And let's take a look at the top left side over here again. We can see that these solid bodies have been imported into different folders. That's to help me organize and understand where everything is. So hardware, I'm not interested in doing simulations on hardware. So what I'm going to do here is on the left, you'll see this. And if I click on this eye, it's going to hide all of those parts. And then you're going to see this crosshair here. And if I click on that, it's going to remove all the hardware from my physics. Now, the hardware will not be in my simulation because that's not something I'm interested in. And for this simulation, we're going to assume that this rear suspension is bottomed out. It's just for simplicity reasons. So we're not interested in the piston or the struts. I'm going to hide those. I'm also going to suppress them in the physics. And lastly, because we are going to do the simulation and assume that this is hinged around this chassis and the chassis is not going to move, there's no reason for me to have the chassis in my simulation either. So I'm going to hide that as well as the physics. Is on this model here, the A-arms, the upright, and the spindle. So before I even start my simulation, I want to take a look at the model itself. I want to make sure that everything is there's no interferences. There's features that look for features I'm not interested in simulating. And I could do that with many of the different tools that Discovery has. One of them is a prepare. And I can look for gaps, missing faces. I'm going to actually head over to display. And I'm going to show, have it look for body interferences. Are there any issues here? And you can see that it's highlighting already in red, that there's some body interferences. Looks like the upright is interfering with the A-arms. So I'm going to triple click this body. What that does is it selects the body itself. Whereas if I do a single click, it's going to be on the face. It's going to be on the adjacent faces. But if I do a triple click, it's going to select the body itself. Now, the next thing I'm going to cover is this cool new feature in the Discovery. They added this halo tool, and it's going to be this black box over here. When I click on this halo tool, it's going to pop open this like a wheel, like a design wheel. And I could go straight into doing some simulations or I could do some modeling. And in this case, I want to use some modeling features to fix this interference. So I click on that, and I have access to the move feature. And now I have the ability to move this upright wherever I want. Now it's kind of difficult for me to make sure it's aligned over using this method here, where I just grab the red axis and I'm moving in the X direction right now. That's not something I want to do. I'm gonna hit escape. And I'm interested in aligning this surface over here where I'm highlighting with my mouse. And I want it to be coincident with this surface over here on the top A arm. So what I'm gonna do is I'm gonna take this yellow ball and I'm gonna move it onto this surface. And now that's where I'm referencing. I'm gonna click on the up to capability, where I get to click on a surface I wanna move this up to. And I'm gonna do this on accident. What if I wanted to move it over here? It's gonna align to that surface I just clicked. But that's not the surface I'm actually interested in. I'm interested in moving this over to the upper A arm. And we have alignment now. So we fixed that body interference. I'm also interested in seeing if there are any gaps. And I can see that there's a gap over here. So I'm using the gap feature. It highlights it over here. That's another part I could fix, the spindle. The spindle is not on the upright. So let's double click that spindle, or triple click it, I'm sorry. We're gonna triple click it, and we're gonna use the halo and get access to that move feature once again. And we're gonna move it, that ball back to that back edge. Okay. And we're going to move it up to this surface over here on the upright. So there you go. Okay. What about these radiuses over here? What if I'm not interested in doing these, using these in my simulation? I could double click and use. I could double click to select all the adjacent radiuses, and by hitting the delete key on my keyboard, or using the fill tool, I can remove that feature. And it was that simple. You can see the feature's gone now. So I'm gonna do that once again, but this time with the delete key on my keyboard. I'm gonna select all these radiuses. I'm at the delete key. Now it's quite tedious for me to have to go through this and continue to select different radiuses. So what I'm gonna do is I'm gonna use a different feature now. I'm going to select this radius, and I'm going to use the power selection feature, and I'm going to ask it to select all rounds it can find that are 1 millimeter. By doing so, I can remove all these features. Similar to these holes, I can click and find all the other, let me see, all equal radius cylinders and hit the delete key and get rid of them. You can just keep going on with these cool defeature tools that you have access to. That's what I like about Discovery. That's what I like about Space Clean. It's meant for somebody that has to fix a geometry because it came in and it's not ready for simulation. Something else I'm not interested in is doing a simulation on these threads, and it's not part of any of our boundary conditions. So I'm going to simply just select all these threads. And I'm going to hit the delete key. And all those threads are gone. It's that easy. Okay, so let's start with the simulation, the Explore simulation. We have this whole suspension assembly, and maybe the first thing I want to study is this spindle. Did we size this spindle? Did we design and size this spindle correctly? for now, I'm actually going to suppress these other parts from our physics. That's the A-arms, the upright. Now let's just suppress those and hide those. And let's focus on the spindle here. And the material that's been selected for is structural. And the first thing I need to do is add a boundary condition where I want to fix this surface. And once again, I'm going to use the halo, very convenient feature. And I'm going to head back. And now, instead of using the modeling tools, I'm going to click on the structure side, where I have access to different types of boundary conditions, displacements, forces, supports, and loads, different bearing loads. So this one I'm going to use a support, and I'm going to fix the surface here. Let me show, I'm going to show the arm again, just so I know as a reference which way I want to apply the force. So on the spindle where my bearings are, I'm going to apply a load now. I'm going to use a halo once again. I'm going to apply a force. Let's say it's only on this surface, so that we can create a moment on this spindle. I have 5,000 newtons. At a slight angle. So I applied my force, and I have the spindle fixed on this side. So now we are ready to start simulation, and I'm going to hit the simulation solve button. So if you look on the bottom right, this is the wheel for the simulation tools, and where we're going to start is we're going to hit the. And we already have the results. So the results that we're looking at, displacement, how much deflection is on the spindle. I'm going to change this to von Mises stress so that we can see the stresses. And we can see that there's a high stress in this area here. I'm curious what features I can use to reduce this stress. So let's track it. Let's look at, let's put some trackers on this. And you can track and monitor various different post processes. For this one, I'm going to track von Mises, and I want to know the max stress. I have a tracker here, and let's see what if I make, as I make changes, is it going to reduce the stress on the spindle? So perhaps I can add a radius to this and see if it reduces the stress. So I'm going to use the halo. I'm going to use the modeling tools in the halo. I'm going to pull this feature. I'm at a small radius, and let's just see if it changes any of the stress results. I'm at a 3 millimeter radius. And you can see the results are happening, right? Make those changes. It's instantaneous. And I can see the stress has been reduced with that change by adding that radius. But I'm not entirely sure if that radius is doing it for me because I don't see the stress dropping that much. Let's assume that I had applied a load where the spindle was going to fail in this area. perhaps the change I need to make is to use different bearing sizes. So what if I grow the diameters or where the bearings would be mounted? Let me try that right now. Let's grow this radius to 32. Let's delete that feature because we can get it back later. And as I'm making these changes, the results are still updating. So what if I went up a bearing size? Let's take a look. Let's go up to 28. I can see the stress in this area has been reduced quite a bit. And my factor of safety has jumped from 7.5 to 9.3. Now I'm going to stop the simulation. And we're going to because now I'm interested in simulation results for the upright. So we're going to replace the location of our fixed support. So Discovery is going to automatically bond surfaces together that are touching. And now I fixed the pivot points here because I want to see the stress on the upright now coming from the loads on this from the spindle. I could see results right away. And I could see some stress concentrations in this feature here. Maybe, no, we're trying to save weight. Maybe this is a feature that we don't need, especially if there's stress concentration from loads happening. So what I can do now, select these surfaces. And I'm going to hit the delete key. Get rid of them. And that already looks better. I don't have those stress concentrations there. And I don't see any red in these areas. So now the upright looks okay. Let's pause the simulation real quick and let's add the A-arms back in. Now here's an important discussion for us. Discovery assumes that all these bodies are bonded together. So what if I'm interested in doing simulations where the A-arms and the upright actually have a joint in between them? That's something I can't do right now in explore mode. But I get access to those type of features if I hop over to Analyze. And there's a lot more I can do with Analyze. So let's hop over to Analyze. And what Analyze is it introduces the Ansys APDL solver that's the That's a simulation solver that's used in Ansys Mechanical today, and it uses it to higher fidelity simulation and get results than Explorer. So what I was using Explorer for was to see instantaneous simulation results, see the changes I make, and see if they're having any benefits at all, and they get those results very quickly and rapidly. And what I'm going to be using Analyze for is to do a higher fidelity simulation. Let's actually go back to that spindle and use that as a good example. I'm going to fix the spindle again. Let me add that radius back in there. Okay. And we're going to hit the solve button. Let me turn the fidelity down because this is for demonstration purposes, so we don't have to sit here that long because it is using your CPU this time. So previously the Explorer solver was using your graphics card to do those rapid and fast simulations. This is going to be the more traditional solver where it uses your CPU. So I'm going to turn the fidelity down so we don't have to wait here for too long. And I'm going to hit the solve button. Let that solve. And I'm going to click show mesh. So what it's doing in the background, it's going to auto mesh this part, and then it's going to solve it. So see, the auto meshing has been completed, and now it's going to solve for us. And this is using the APDL, which is pretty robust and a pretty high fidelity compared to other simulation softwares out there in the world. Now, the mesh looks kind of coarse. I do have options in the simulation tab to add some local refinements. So I can select this face over here and this one. So these are the faces that I'm interested in adding some local refinements. Try that again. It's going to ask me for a value. And let's just make it 1 millimeter. And let's resolve that. And let's mesh and let it auto mesh for us. You can see a much more fine mesh on the surface here. And because it's a higher mesh, it does take a little bit longer to solve. If you guys like what you see today, please contact us. Let us know, or fill out the survey at the end of this webinar and let us know that you're interested in the Ansys tools. One of our sales representatives will get back to you. It's taking a little longer. Let me see if I have one for the spindle. Launching progress. That's okay. Let's just start over. I'd like to move on to our next subject. Delete this refinement. It's going to take too long to solve, so I just stopped it. Okay, and let's go a level up. Just like we were doing the Explore side, let's go a level up on the Analyze side. I'm going to bring in back in the upright. To physics. Huh. Acting a little funny. Let me open up this. Okay. Let me close this down. The program's acting a little funny right now. I'm reloading Discovery again. Okay, this time we're going to do a simulation. Now I'm going to show you with the Analyze tool, we get access to some more and contacts. I'm going to show you guys what contacts are right now, just in a second. Let me play some catch up. And I'm interested in doing a simulation with these 3 bolts here. Oh, you know what? I have to realign this. 1 second. Okay. Okay. So I'm going to do a simulation with these 3 bolts in the simulation, because I'm interested in how the hardware is going to hold together. And I'm not interested in the other hardware, so I'm going to select these 3 and put them in their own folder. To a new component, and you can see that hardware got moved over here. So now I can suppress all the other hardware and hide them. Okay. So let's fix these ends over here. so we can fully constrain the upright. So by default, in analyze mode, it's going to every single body to be bonded together, because that lets you do a simulation right away. It's fully constrained. What I'm going to do is I'm going to tell that, I'm going to turn that off. And I'm going to manually set the contacts that I'm interested in. So let me hide this spindle. And I'm interested in these two bodies. Let me see here. Rather, you know what? Let me do it this way. Let me tell it to bond everything, and I'll override the other contacts. Sorry. Let's see here. I'm going to everything to be bonded because we're going to override other contacts. All right. That makes it easier. That way, all these 3 bolts are going to be bonded to the upright. Reshow the spindle. So I'm going to make a contact between the spindle. You know what? I'm going to allow these surfaces to slide against one another. Next contact I'm going to do is within these holes. I want to make sure that the hardware is not bonded to them, because I know they're pretty close and the program might bond them together. So I'm going to tell it to not have any type of contact between these two. Just reshow that upright. Okay, and let me analyze and load. Okay, we need that load back. Let's do 5,000. And let's let that solve. So I see it's 10:45. I actually saved the simulation, so have to watch it solve. Let me just open up the simulation results. Here. Report button. See bolt pretensions. Yeah, let me open up the one I solved already so that we can see the stress on the hardware. By the way, please feel free to ask some questions, and we can do the Q&A session during these times too. See, so we can see an exaggeration of this. Where are my bolts? They're not showing. Make sure the hardware is being shown. Hardware should be in there. We can see that even though we optimize the spindle, we can see that there's a very high stress concentration because technically we're not welding the spindle to the upright. We were using hardware to hold it together. And because it's not bonded, you can see by using the analyzing tool, we can find other areas that need to be optimized. And one of them is here. Perhaps 3 bolts isn't enough. Maybe we need to add more bolts in the bolt circle. And I know it's 10:47, so where I wanted to take the simulation next, but I'm certain that we won't have time. I wanted to do a full on the arms as well. I was going to add the arms in here, and what we were going to do was we were going to add relationships between the upper arms. So let me set those up actually really quick. We're not gonna hit the solve button, but we're gonna add other contacts that we have accessible in the analyze solver. So in there. Let me open up the fully solved one. This one's a bigger simulation, so it might take longer to open. Okay, so take a look on the left side of the physics area, and you can see I use the boundary conditions of hinging. So I hinge them in space, like a door hinge. They're able to rotate around these axes, or rather this cylindrical surface. It's allowed to rotate. And the next thing I did was I added joints. And these joints were added between the upright and the arms. And this is all done in the Analyze solver. What you see here, simulation results for this, but instead of everything being bonded together, there's now a hinge relationship, so we can exaggerate that deformation and take a look at this. And this is a case where the strut and the suspension has been bottomed out, and assuming that maybe we needed to do a design change to our suspension itself, also optimize these areas, because if the strut and the spring bottoms out, then we're going to get really high stresses in this area. So that concludes our Discovery Live. I'd like to open up and welcome you all to our next AVA session. It's going to be run by my colleague Snigdha Sakar, and she's going using design exploration tools for Ansys Fluent. So be on the lookout for that. If you want some details on it, please visit our events page. Also, if you're interested in anything you saw today and you'd like to try Ansys Discovery or any other Ansys products, please give us a call or email us. That concludes today's AVA session. Thank you all for joining. Appreciate your time.